Hello everyone, welcome to Savi tutorial on fluid mechanics and hydraulic machines laboratory. So today we are discussing experiment on determination of coefficient of discharge of a broad crested weir. Okay, so the aim of the experiment is to determine the coefficient of discharge for a given weir. So the apparatus required are weir experiment setup, broad crested weir and a stopwatch. So coming to the theory, first of all, what is weir? See, weir is a structure. It is a masonry structure, so which is constructed across the river, okay, or an open channel to measure the rate of flow, okay, to measure the discharge. So weir is also one of the structure which is used, and also it, sometimes this weir is used to, drain out the excess water, okay, so from the dam or reservoir. So we have various types of weirs like rectangular, triangular. So based on the shape and based on the different parameters, so we have different types of weirs. So here, so we have two types of weirs, that is a broad crested weir and the narrow crested weir. So which is classified based on the head of water or the water level over the weir. So that is, so twice the length, that is L is the length of the weir. So if the 2 times the length is less than the head over the weir, for example, if you take this is a weir, okay, so this is the length, okay, so this is the length of the weir, this is the length of the weir, and so water will flow over this weir, and this is the head, this is the head H. So if 2L, that is twice the length of the weir, is less than the height, then it is called narrow crested. So if twice the length of the weir is greater than the head over the weir, then it is classified as a broad crested weir. Okay, so here we are all discussing about the broad crested weir. So here we are determining the coefficient of discharge, that is CD, for a broad crested weir. So let us just see what is the procedure. So first what you have to do, see, you will be having a channel. Okay, so this is a channel. So first you have to fix a weir inside the channel. So you have to fix a weir. So this is a weir. So you have to fix a weir inside the channel, and after that you have to switch on the pump. Okay, and very first you have to note down that whether the sump has a water or not. So, okay, sump will be filled with the water. So and from this sump you're going to allow water to flow through this channel. So first you have to fill the water till this crest level. So this is called the crest level of the weir. So till this particular point you have to fill the water. Okay, and you'll be having a hook gauge here to record the head over the weir, that is a capital H. Okay, so you have to record the initial reading after filling the water till this crest level. So you have to note down the initial reading. Okay, so that is the initial reading, that is initial reading of the water level. So after that you increase the discharge. Okay, so you increase this discharge, then more amount of water will flow over the weir, so will flow. So where at that particular case water will flow over weir like this. Okay, so there is an increase in level now, increase in water level. So that is your final reading. Okay, so initial reading, so till the crest level. Okay, and after that the final reading, so after increasing the discharge. So this initial minus final will give you the head over the weir. So you can see initial reading minus the final reading is the head over the weir, that is capital H. So once you get this H, so then you repeat the experiment for the different discharge values, for different Q values. So increasing the discharge, so you will get the initial minus the final again. So you will get the H values. And here the data which you have to note it down are area of the collecting tank, acceleration due to gravity, and length of the weir. So these are the observations what you're going to record. So which you're going to use to do the calculation. So let us see the formulas which are used to find out the coefficient of discharge. Coefficient of discharge is the ratio of actual discharge to the theoretical discharge. First we have to calculate the actual discharge, and later we have to calculate the theoretical discharge. So here, so actual discharge is calculated, so using the same formula, that is AR by T. See here, see once the water flows over the weir, so what you have to do is, so that water will flow through this channel and gets collected in the collecting tank. So and that collecting tank will be having a piezometer, so where you're going to record the time. Okay, so that is time taken by the collecting tank to deposit 10 centimeter head of water using a stopwatch. So you have to record the time taken by the collecting tank to collect a 10 centimeter head of water. Okay, so that time is used to calculate the actual discharge. Okay, so once water flows for each trial, you have to note it down the time. Okay, so once the water flows over the weir, so it gets collected in the collecting tank. Okay, so that before that you have to close the butterfly valve of this collecting tank, or then only the water will gets collected. So this water gets collected in the collecting tank, so you have to note it on the time taken to collect 10 centimeter head of water. Okay, so using that data, that is uh, the collecting tank details, you're going to get the actual discharge. So that is Q actual is equal to A into R by T. So where the time you're going to record for each trial, and the capital A is the area of the collecting tank, and R is the rise of water, that is 10 centimeter rise of water in the collecting tank. And we have the theoretical discharge formula. So to calculate the theoretical discharge for a broad crested weir, so that is Q theoretical is equal to 1.705 L into H to the power 3 by 2. So this is the formula to calculate the theoretical discharge for a broad crested weir. So once that is using the length will be given, you are going to note it down the length of the weir, and the head, so you will be having different head for different trials. So using that you will get theoretical, and later using the time of the collecting tank you will get the actual discharge. So once you get the actual and theoretical, you will get the coefficient of discharge. So if you see the tabular column, it is like this. See height of the water above the crest, that is initial minus the final reading. Okay, so and the collecting tank reading, so that is a rise in water level, it is 10 centimeter, and the time for each rise, for each trial, you'll get the different time intervals. So this remains same, the 10 centimeter. Okay, so you'll get different times and different heads. So using that you'll get a actual discharge, that is AR by T, and theoretical discharge, it is 1.705 L into H to the power 3 by 2. So you'll get different theoretical discharges. So and the ratio of actual to the theoretical discharge, you'll get the coefficient of discharge, and take the average, that will be your coefficient of discharge for the given broad crested weir. So the result will be coefficient of discharge for a given broad crested weir. And similarly, see experimental setup is like this. You can see here we have a channel. See, this is a channel, and you can see this is a broad crested weir, and you have a hook cage to measure the head over the weir, and the specifications are mentioned here. So area of the collecting tank and length of the weir. Okay, and this is a collecting tank. Okay, where you have a piezometer here, and this is a sump which supplies the water, and this is a valve to regulate the discharge. First, what you have to do is you have to fill the water till this crest level. So this is a crest level. So till here you have to fill the water, and after that you have to make the point gauge, and you have to note, you can make it to 0, or you can record this level of water once you fill the till the crest level, that is your initial reading. So after that what you have to do is you have to increase the discharge. Okay, so first of all you have to switch on the pump. Okay, the green color button is is a to switch on the pump. So after that you have to increase the discharge, then what happens, the water will flow over weir like this. Okay, it will flow over like this. So this is a new level. So now using this point gauge you have to measure this final reading. So this is the increase in water level. So the difference between these two, you will get the head. Okay, so and for the same trial, so what you have to do, water will flows over the weir and gets collected in the collecting tank, and you have to note it down the time. Okay, for 10 centimeter rise in water level inside this collecting tank, and before taking you have to close this butterfly valve. So this is a butterfly valve, you have to close it. So then water starts collecting in the collecting tank, and you have to record the time taken to rise a 10 centimeter water. And after that you have to open this valve. The water will flow from the collecting tank to the sump. Again you have to increase the discharge. You increase the discharge, again there is an increase in water level. Okay, so like this you will get a new water final reading, initial reading. You'll get new H, and again you will get new T. Okay, so and again the procedure repeats. So this is how you're going to conduct the experiment on broad crested weir. Thank you all. So in the next video, we'll see the next experiment.